Alright guys, this is Mr. Dove, and with this video recording I'd love to be able to talk a little bit and review the osmosis homework from the previous evening so you can better understand the process of osmosis. Osmosis can basically be defined as the diffusion of water. And so when we're talking about diffusion, we're talking about molecules moving from an area of high concentration to an area of low concentration. Um, and in the case of osmosis, we're crossing a semi-permeable membrane. So when we say diffusion, we're talking about the movement of a molecule. And with osmosis, that molecule is always going to be water. So down here we have three different cells. Each of the cells have a certain amount of water and a certain amount of salt. And so that's going to be the internal solutions of our cells. Now, cells react differently depending upon the solution that they're placed in. They're either going to shrink, they're going to swell, or they're going to stay the same. The thing is, when we're talking about osmosis, remember it's water that moves. So water has to go from high to low concentration. If you have a high amount of water, high concentration of water, that means you're going to have a low concentration of solute. If you have less water, that means you're going to have more solute. So in the case of our first diagram, our cell has 98% water and 2% salt. Outside of the cell, we have 95% water. So that means that there's more water on the inside. So as a result, the water is going to move out of the cell to an area of lower concentration to try to equal out that concentration. Because the salt can't move, that's what's setting up the concentration gradient. So because the cell is losing water, we will say that it is going to shrink. Now, how do we describe the solution that the cell is in? Well, it has a higher concentration of salt. It has 5, while in the cell there's only 2. The term that's used to describe a high concentration is hypertonic. So our cell is in a hypertonic solution because there's hyper, more solute, and less water. And water goes from high to low concentration. In our next scenario, we have some water and in the cell and water outside the cell. If you look, they're exactly the same. So if a cell is in a concentration of solution that's the same, then it's going to just stay the same. It will not change. The term we use to describe a solution that is the same as the inside and out is isotonic. Iso is a prefix which means the same. Like in geometry, an isosceles triangle has equal sides and equal interior angles. Now, if each of these is representing one of the solutions, then by process of elimination, this has got to be a hypotonic solution. But more than that, we want to understand why it's hypo. Hypo means low, a low concentration of solute. So we have 0% solute versus 2, so there's very low solute in the surrounding solution. There happens to be a lot more water though. Water goes from high to low concentration. So it's going to go into the cell, and so as a result, our cell is going to swell. So these cartoon diagrams, they set us up with our salt concentrations and water concentrations, and we just illustrate which way the water flows. Hopefully you'll be able to do that. If you're given a particular salt concentration, you'll be able to figure out what's left over in water and then determine that high to low concentration. Remember, the thing to remember is that salt sucks. Water will move to where there's more salt or more solute. Now, in our second scenario here, we're actually given a released test item from a New York Regents test. Fortunately, on your SOLs, you don't have to give any short answers, but I feel like if you can answer a short answer, then you're very well versed in being in the topic and you're able to do well on even a multiple choice item. So in this case, the student is preparing a wet mount slide of an onion and observes it under high power. And then after a while, after adding salt, something happened. And so you're asked to describe what happened and explain why. So to really be able to describe that, perhaps we need to see that. So let's take a look at this in real life. Here we've got our red onion cells. The cytoplasm of the red onion has a red pigment in it, which makes it easy to see any changes that are happening in the cell. So if we start paying attention, we're noticing that the cell wall is pretty much staying in place, but the cell membrane is shrinking away. So if you think from the previous question we just answered, you know, what makes cells shrink? Under what conditions would cells shrink? So if we look back at the top, which one had the cell shrinking? Well, that was that hypertonic solution. So the cell shrunk, and we can see that in the picture because here we have a full cytoplasm, and here the cytoplasm is shrunk to the center. And so why did it shrink? Because it was placed in a hypertonic solution. So cells shrink in hypertonic solutions, they swell in hypotonic solutions, and they stay the same when it's isotonic. Hope this helped explain your homework. Good luck, and I'll see you next time.